Hello students, in the last sessions we have seen something on group 17 elements. Today I shall take up with the last part on group 18 elements, which are also called as noble gases. Now, in this you might have already studied the names of these noble gases. So, it starts from helium. I have helium with the symbol He, neon Ne, argon Ar, krypton Kr, xenon Xe, radon Rn, and oganesson Og. See, this you might not have heard about this oganesson. This is an element with atomic number 118. Last element ನಮಗೆ ಈಗಾಗಲೇ ಗೊತ್ತಿದೆ periodic table ಅಲ್ಲಿ 118 elements ಇದೆ ಅಂತ ಹೇಳಿ. The last element is oganesson. Okay, so this one is a new entry now. It was not named. Now IUPAC name ಅಲ್ಲಿ unknown whatever octium ಅಂತ end ಮಾಡ್ತಿದ್ವಿ, but now it is named as oganesson. Okay, and now the study of this is not given to you, but it is mentioned. Okay, I have told you, right. Now see, these are the noble gases, or they come in the group 18 of the periodic table, which are placed at the extreme end of the periodic table over there last. I hope you have seen a periodic table, so just recall those where exactly it is placed. Okay, now if you see here, they are all called as noble gases because of their zero reactivity. They are also called as rare gases, since they are present in minute quantity as such. Okay. Now we shall see some of the properties given with respect to these noble gases. So first comes the occurrence. How exactly or where exactly do we find these noble gases? See, noble gases are generally present in atmosphere except radon, Rn. Rest all are present in atmospheric air. So radon, so this being radioactive, okay, I will write it here. The study is not limited, and only one line is said about oganesson in the new versions of the textbook. So this might also be radioactive. It is generally study is not given to you over here. Our study will limit till radon only. Okay, just one line they have given in your text, but I have told you, just remember this one. So except radon, radon ಒಂದನ್ನು ಹೊರತುಪಡಿಸಿ ಮತ್ತೆಲ್ಲದು atmospheric air ಅಲ್ಲಿ ಇರುತ್ತೆ, but very small amounts, less than even 1%. 1% ಇಂದನೂ ಕಡಿಮೆ ಇದೆ. Now in that case, argon, this is usually present in large amounts. Okay, so ಇರೋದೇ ಕಡಿಮೆ, ಆ ಕಡಿಮೆನಲ್ಲಿ ಇಷ್ಟು ನೋಬಲ್ ಗ್ಯಾಸ್ನಲ್ಲಿ ಆರ್ಗಾನ್ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಪ್ರಮಾಣದಲ್ಲಿ ಇರ್ತದೆ, ಲೆಸ್ ದೆನ್ 1%. ಸೊ ಜಸ್ಟ್ ರಿಮೆಂಬರ್ ಅರೌಂಡ್ 1% ಇರುತ್ತೆ. ಆ 1%ನಲ್ಲಿ ಜಾಸ್ತಿ ಇರುವಂಥದ್ದು ಆರ್ಗಾನ್ ಇನ್ ಕಂಪ್ಯಾರಿಸನ್ ವಿತ್ ದೀಸ್. ದೆನ್ ನಿಯಾನ್ and helium, they are usually seen in some of the radioactive minerals like pitch blende, monazite, etc. So radioactive mineral source nalli we find some of these helium and neon. Commercial source of helium is given. Commercial source of helium. Helium is natural gas. Okay. So, this the commercial source of helium will be natural gas. So, this is something regarding abundance or how are they found in small amounts. Next I said radium is radon radioactive. So, this is usually how do we get radon now? It is obtained by radioactive decay of radium. So, you know radium is the next element which comes next to this radon. So, I have that Ra, this undergoes decay to end up with radon with the helium. So, it is here it is 88 and it is 86 here in 226 and 222. So, radioactive decay of radium will end up with radon with the emission of alpha nucleus. Now, I said something on oganesson also, right. This oganesson is generally obtained from the radioactive decay of californium from while treatment with the calcium. So, that is one point given over there. So, this is regarding the occurrence of these noble gases. Next, we shall move on to some of the physical properties or periodic properties. How do they vary for these noble gases? Remember the names: helium, neon, argon, krypton, xenon, radon and new element oganesson. The last element in the periodic table with atomic number 118 is Og, which is nothing but oganesson. Okay. Next, we shall continue with some properties. So, first I have electronic configuration. Now, if you say something regarding electronic configuration, you know that since they are placed at the end of the periodic table, their general electronic configuration is Ns2 Np6. They contain 8 electrons in their valence shell or the valence shell is completely filled. Now, this configuration is for all elements except helium, He. So, He has an electronic configuration of just 1s2. So, there is no p orbital in helium, but it will satisfy all those properties of noble gases and hence it is placed in that group 18. Okay. Except helium, they have the completely filled shells. Next, if I move on to atomic size. So, it is seen that the value of atomic size decreases on moving down the group. So, the size decreases down the group. If we come down from helium to radon, the size will decrease, size will increase. I am very sorry students. So, the size increases because you know here first it is 1s, the next I have 2s and 2p for neon, 2s2, 2p2, 2p6, argon, 3s2, 3p6, so on, 4s, 4p, 5s, 5p, 6s, 6p and last for oganesson 7s, 7p. So, that will be filled over there. Now, generally the size increases because you know the electron enters into the new shell and hence the distance automatically increases, but whenever you come down the group the size also increases. Next one, ionization enthalpy or ionization energy. You know that ionization energy is nothing but the energy required to remove an electron. Now, since they have this completely filled shells, removing an electron from this stable configuration is very, very difficult and hence the values of ionization energies are all high. They have high ionization energy, but if you come down the group from helium to radon something as such, the value decreases. So, this decreases down the group. Okay, since they have the stable and electronic configuration, it is not possible to remove an electron, and hence ionization energy values are high. Next, electron gain enthalpy. Now you know that electron gain enthalpy, what we do? We add an electron. So whenever we are adding an electron, what generally happens? So some amount of energy will be released. Now if you see students here, in this case what happens is, even it also has got the completely filled shell. Now if you add an electron to this, where will the electron go? Electron ellige hogutte? A shell igagale complete agide. So in that case, the electron should enter into the new shell, which requires certain higher energy, and hence they have got large positive values of electron gain enthalpy. The value, you know that usually samanyavagi a electron gain enthalpy enagirutte, it is the energy released, the value will be negative, but for these noble gases the value will be positive, since they have completely filled shell. The added electron enters into the new shell, which requires certain energy, and it is not possible, and hence they have large positive values of electron gain enthalpy. So since they cannot take up electron, we do not comment anything on electronegativity as such. So the next we will move on to some of the physical properties given over you. So rest that is usually physical properties. I will write here physical. If you just see physical properties, students, so these, they all are monoatomic gases. This you already know. So somewhere in last year where in which well saying something on bond order, He2 does not exist anta helidvi ನೆನಪಿದೆಯಾ? He2 ಈ molecule ಇಲ್ಲ ಅಂತ. Why? Because there is no bond between two helium atoms. So ಹಾಗಾಗಿ they exist as monoatomic gases only. They are not seen as diatomic gases. ಈಗ O2, F2, H2 ಆ ಥರ ಎಲ್ಲ 2 ಇತ್ತಲ್ಲ, ಇಲ್ಲಿ 2 ಇಲ್ಲ, 1 ಮಾತ್ರ. ಹಾಗಾಗಿ HENE ಹಾಗೆ ಬರೀಬೇಕು. We don't see, because if you calculate bond order writing all those electronic configurations, it will end up with 0 bond order, showing that the molecule does not exist, and hence they exist as atoms, or that is monoatomic gases. Then melting points and boiling points, they are I will write one point here only, they are colorless, odorless and tasteless gases. Okay, colorless, odorless, color illa, odor illa, hagagi taste kuda illa, and they are sparingly soluble in water. Sparingly indra ಸ್ವಲ್ಪ ಸ್ವಲ್ಪ, they are sparingly soluble in water. If you see the melting points and boiling points, so these are usually low. Okay, the melting points and boiling points of all these whatever so called noble gases, they are low. Especially helium has got the lowest boiling point, around 4.2 Kelvin. So this low. Now why do they have low boiling point? So that is main reason, because of the presence of weak forces of attraction, ಅಥವಾ intermolecular force of attraction ಅಂತ ನಾವೇನು ಹೇಳ್ತೀವಿ, that is due to weak dispersion forces. So due to the presence of weak dispersion forces, melting points and boiling points of noble gases are very, very low. So only one type of interactive interactions are seen. ಯಾಕೆ ಅವು ಯಾವುದು ಮೊನೋಅಟಾಮಿಕ್, ಡಯಾಟಮಿಕ್ ಏನಲ್ಲ. ಸೊ ಹಾಗಾಗಿರೋದ್ರಿಂದ ಇಂಟರಾಕ್ಷನ್ಸ್ ಏನಿರುತ್ತೆ, ಸೊ ಅವೆಲ್ಲವು ತುಂಬ ವೀಕ್ ಡಿಸ್ಪರ್ಷನ್ ಫೋರ್ಸಸ್. ಯು ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್ ಟೈಪ್ಸ್ ಆಫ್ ಫೋರ್ಸಸ್ ಇನ್ ದ ಸ್ಟೇಟ್ಸ್ ಆಫ್ ಮ್ಯಾಟರ್. ಅಲ್ಲಿ ಡಿಸ್ಪರ್ಷನ್ ಫೋರ್ಸಸ್ ಬರ್ತದೆ ಅಥವಾ ಲಂಡನ್ ಫೋರ್ಸಸ್ ಅಂತ ಮೆನ್ಷನ್ ಮಾಡ್ತೀವಿ, ಡೈಪೋಲ್ ಫೋರ್ಸಸ್, ಇಂಡ್ಯೂಸ್ಡ್ ಡೈಪೋಲ್ ಫೋರ್ಸಸ್ ಸಮಥಿಂಗ್. ಸೊ ಹಿಯರ್ ಬಿಕಾಸ್ ಆಫ್ ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ವೀಕ್ ಡಿಸ್ಪರ್ಷನ್ ಫೋರ್ಸಸ್, the boiling points and melting points of these noble gases are low. In that case, helium has got the lowest boiling point of around 4.2 Kelvin. Okay. This is regarding the physical properties given to you students here. Next we shall move on to chemical properties. Physical properties are over students. Next we shall come back to chemical properties. See, these noble gases, they are also called as inert gases since their reactivity is 0. Now, even here also they are least reactive or they are unreactive. Least reactive anta helik baralla, unreactive. Now, why are they unreactive? What are the reasons? So, they all are unreactive. So, the reasons for them to be unreactive are, there are two reasons. One, they contain completely filled valence shell, or they have the stable NS2 NP6 configuration. So, this is one point. See, now first one we know that like now reactivity anna helbekadre electron anna tegedu reactivity heltivi illa electrons anna haki reactivity anna helteve. Now in this case they have completely filled shells. Illi electron tegiyudagli illa hakudagli it is not possible, and hence andre ಒಂದು stable configuration ಇದೆ, ನಾವು unstable ಗೆ ಕರ್ಕೊಂಡು ಹೋಗ್ತಿದ್ದೀವಿ, so which is not possible, and in that case the reactivity will be 0. And one more reason is, see, ಈಗೇನೋ ಇಲ್ಲ ನಾನು ಎಲೆಕ್ಟ್ರಾನ್ ಹಾಕ್ತೀನಿ ಇಲ್ಲ ಎಲೆಕ್ಟ್ರಾನ್ ತೆಗಿತೀನಿ ಅಂತ ನೀವು ಮಾಡಿದರೆ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇಫ್ ಯು ವಾಂಟ್ ಟು ಆ್ಯಡ್ ಅನ್ ಎಲೆಕ್ಟ್ರಾನ್ you will be subjecting it to, or you will end up with an electron gain enthalpy values, or if you are removing an electron you end up with ionization energy. What will be the values of those? Will they be low? No, they will be high, tumba high value barutte. And the other reason is they have high ionization energy, I will write it as IE, and large positive values of electron gain enthalpy. If you want to remove an electron, we have to provide energy, that energy will be very, very high, ionization energy. Or if you want to add an electron, ಒಂದು electron add ಮಾಡ್ತೀರಿ ಅಂತಂದರೂ ಕೂಡ ಆವಾಗ add ಮಾಡಿದ್ದು I have already said the electron should enter into the next shell, so which requires higher energy, and that values will also be very, very high, that is large positive values. So these are the two reasons by means of which there is no chemical reactivity for these noble gases. Okay, till the development andre till 1950s 1960s ತನಕನೂ ಯಾವುದೇ ರೀತಿಯ ರಿಯಾಕ್ಟಿವಿಟಿಯನ್ನು ನಾವು ನೋಬಲ್ ಗ್ಯಾಸ್ಗಳಿಗೆ ಮೆನ್ಷನ್ ಮಾಡೋದಿಲ್ಲ, ಬಟ್ ಇಟ್ ವಾಸ್ ಇನ್ 1962 recent development, Neil Bartlett so this fellow Neil Bartlett, what was he doing is he was preparing a compound like this O2 PtF6, so O plus and this PtF6 minus. So ಇವನು ಈ ಕಾಂಪೌಂಡ್ ಅನ್ನು ತಯಾರು ಮಾಡ್ತಾ ಇರ್ತಾರೆ ಇವರು. So what he'll do is he'll compare the ionization energies of that molecular oxygen with the xenon. See, oxygen having an ionization energy of 1170 Kelvin, sorry 1170 kilojoules, joules, extremely sorry, Xc with the ionization energy of 1175 kilojoules per mole, that energies. Okay, for oxygen it is 75, ulta barde, sorry, and for this ಈಗ ಏನದು ಒಂದು 5 kilojoules ಅಷ್ಟು ಎನರ್ಜಿ ಮಾತ್ರ ಡಿಫರೆನ್ಸ್ ಇದೆ. Now he will take that xenon and will make it to react with platinum hexafluoride PtF6. He'll take this, ಅಂದರೆ ಆಕ್ಸಿಜನ್ ತೊಗೊಂಡು ಮಾಡ್ತಾನೆ ಈ ಕಂಪೌಂಡ್ ಬರುತ್ತೆ, ನಾನು ಯಾಕೆ xenon ಅನ್ನು ತಗೊಳ್ಬಾರ್ದು ರೀಪ್ಲೇಸಿಂಗ್ ಬೈ ಆಕ್ಸಿಜನ್, ಆ್ಯಂಡ್ he was successful in ending a compound of xenon, which is nothing but XePtF6, that is xenon hexafluoroplatinate 4. So, this one was the first noble gas compound prepared by Neil Bartlett. So, in comparison with the ionization energies of molecular oxygen, he replaced this oxygen by taking xenon and was successful in getting the first noble gas compound. So, ಒಮ್ಮೆ ನಮಗೆ ನೋಬಲ್ ಗ್ಯಾಸ್ಗಳು ರಿಯಾಕ್ಟ್ ಆಗಿ ಕಾಂಪೌಂಡ್ಸ್ ಬರುತ್ತೆ ಅಂದಮೇಲೆ ತುಂಬ ಸೈಂಟಿಸ್ಟ್ಗಳಿದಾರಲ್ಲ, ಸೊ ಅವರು ಇನ್ನಷ್ಟು ಸ್ಟಡಿ ಮಾಡ್ತಾರೆ. ಆ್ಯಂಡ್ ನೌ ವಿ ಹ್ಯಾವ್ ಮೋರ್ ಕಾಂಪೌಂಡ್ಸ್ ಫಾರ್ xenon that we shall study now. So, we have more few compounds ಅಂದರೆ highly reactive elements like fluorine and oxygen. They react with xenon to get compounds for xenon. We have two set of compounds, that is xenon oxygen compounds and xenon fluorine compounds, which I will discuss now. And other than this xenon, there are certain compounds for krypton also have been identified, that is difluorides KrF2. So, this has been identified, only one difluoride for this one krypton. Even for radon also it is identified RnF2, but idu isolate ಮಾಡಲಿಕ್ಕೆ ಆಗ್ತಾ ಇಲ್ಲ. This has been just identify ಮಾಡಿದ್ದಾರೆ ಅಷ್ಟೇ, but it could not be isolated. Later stages nalli may isolate and we might have to study in future days as such. So, ರೇಡಿಯೋ ರೇಸರ್ ಟೆಕ್ನಿಕ್ಕಿಂದ RnF2 ಅನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡಿದ್ದಾರೆ, ಸಪ್ರೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಆಗಲಿಲ್ಲ. ಬಟ್ ಫಾರ್ ಕ್ರಿಪ್ಟಾನ್ ವಿ ಹ್ಯಾವ್ ಓನ್ಲಿ ಒನ್. ರೆಸ್ಟ್ noble gases like I have helium, neon and argon. So, idakke the compounds are not yet known. The compounds for the helium, neon and argon, they are not known. Only more compounds for xenon have been studied, isolated, and a few, only one for krypton, and this has been identified and yet to be isolated. Now, next we shall move on to certain xenon compounds with oxygen and with fluorine. We shall take up xenon fluorine compounds first. Xenon fluorine compounds. So, three types of compounds have been isolated: difluoride, tetrafluoride and hexafluorides for xenon, that is in general xenon fluorides, XeF2, XeF4 and XeF6. So, these are the compounds of xenon with the fluorine: difluoride, tetrafluoride and hexafluoride. Now, if you take the preparations of those, we shall look into the preparation. Simple preparations have been given, direct mixing of the two. First, if I take xenon and I will treat it with the fluorine, wherein which here I will take Xe is taken in excess at a temperature of around 673 Kelvin and under 1 bar pressure. So, I will end up with direct XeF2 only. Okay. Next, if I increase the number, I will take Xe with the 2 molecules of F2 in the ratio of 1:5, slight higher temperature of 873 Kelvin and 7 bar pressure. I will end up with XeF4, that is hexafluoride. If I want to get the other type of XeF6, I will take Xe and 3F2 in the ratio 1:20 for about 573 Kelvin temperature, around 60 to 70 bar pressure. ಸ್ವಲ್ಪ pressure ಜಾಸ್ತಿ, so ಆವಾಗ we will end up with XeF6. Okay, so these are certain methods of preparation. Even you can take XeF6 anna, if I take XeF4 and if I treat it with O2F2, dioxygen difluoride, an oxide of fluorine. So, iದ್ರ ಜೊತೆಗೆ ಟ್ರೀಟ್ ಮಾಡಿದ್ರು ಕೂಡ ನನಗೆ ಏನು ಬರ್ತದೆ, I will end up with XeF6. These two will added over here and plus O2. So, these are the few methods of preparing compounds of xenon with fluorine. ನೀವು ರೇಷಿಯೋ ಎಲ್ಲ ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ತಾ ಹೋದ್ರಾಗ ನಮಗೆ ಬೇರೆ ಬೇರೆ ಕಾಂಪೌಂಡ್ಸು ಸಿಗ್ತಾ ಹೋಗ್ತದೆ. ಇಫ್ ಐ ಟೇಕ್ 1F2 under these conditions of temperature and pressure, I end up with xenon difluoride. I'll take 2 in the ratio of 1:5. At these temperatures, I'll end up with XeF4, and lastly with 3 molecules of F2 in the ratio of 1:20, I end up with XeF6. XeF6 ಅನ್ನು XeF4 ಇಂದ ಪಡ್ಕೊಳ್ಬೋದು by treating with O2F2 as it is. I'll end up with this one. Next, if we go to the properties of these xenon fluorine compounds, I'll write here. So, they all are good fluorinating agents. Fluorine ಇರೋದ್ರಿಂದ ಇವನ್ನ fluorinating agents ಆಗಿ ನಾವು ಯೂಸ್ ಮಾಡುವಂಥದ್ದು, and they generally are easily hydrolyzed by water. So, even a small amounts of water idru saku, they readily undergo hydrolysis. One example given to you here is XeF2 reacting with water is given to you, which will end with the general Xe bartade and HF and O2. If you just balance this, I want 2H2O and we'll end up with 4HF. 2Xe, 2XeF2. I hope it is balanced. This is balanced. So, if you have small amounts of water also, this readily gets hydrolyzed and I end up with the Xe will be ending back and HF bartare, hydrogen fluorides as such. And one more told to you here is they all react with the fluoride ion acceptors. So, they react with these fluoride ion acceptors and we end up with 2 different species. One cationic species barutte to end up with the cationic species, and those fluoride ion acceptors enirtadalla, they are those fluoride ion donors enirutte. So, they form fluoro anions. So, I will write one equation for you here, a simple one given to you, XeF2 with the PF5. So, ಇದು general difluorides, these are fluoride ion acceptors. ಈಗ ಏನು ಮಾಡುತ್ತೆ ಅಂತ ಹೇಳಿದರೆ ಒಂದು ಫ್ಲೂರಿನ್ ಇಲ್ಲಿಂದ ಇದಕ್ಕೆ ಹೋಗ್ತದೆ, they are the acceptors of fluorine. So, ಹಾಗಾಗಿ ನನಗೆ ಏನು ಬರ್ತದೆ ಅಂದರೆ I have XeF with a positive sign and this will PF5 ಏನದು fluoride ion acceptors will take one fluorine and will end up with PF6 minus. ನೋಡಿ ಇದು cationic species positive charge and anionic species in generally fluoro anions. Even you can take XeF4 ತಗೋಬೋದು with some other, I will take antimony SbF5 fluoride ion acceptor ಆಗಿ SbF5 ತಗೊಂಡ್ರೆ ಒಂದು ಇಲ್ಲಿಗೆ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ ಅಷ್ಟೇ. So, I have XeF3 plus and SbF6 minus. Simple as such. So, these they end up with cationic species and fluoro anions. So, these are the things given to you in the case of properties, and all those dihalides, tetrahalides ಮತ್ತೆ hexahalides ಏನಿದೆಯಲ್ಲ, they all are crystalline solids and they are readily sublime at 298 Kelvin, and some of the properties I have told, they act as good fluorinating agents and they are easily hydrolyzed by water and they generally react with fluoride ion acceptors to form 2 sort of ions, that is xenon containing gets converted to cationic species while the fluoride ion donors ಏನಿದೆಯಲ್ಲ, so those they get converted to fluoro anions. So, this is regarding xenon fluorine compounds. Next we shall move on to xenon oxygen compounds. After xenon fluorine compounds, next we have xenon oxygen compounds. One compound is very important. We generally have XeO3 and one more is XeOF4 and lastly XeO2F2. So, particularly with oxygen is XeO3, with fluorine I have 2 XeOF4 and XeO2F2. So, two preparations have been given, one for XeO3 and those two also have been given. We will still see one by one preparation. Preparation is usually by the hydrolysis of XeF4 or XeF6. ಏನು xenon tetrafluoride ಅಥವಾ hexafluoride ಏನಿದೆ ಅದನ್ನು hydrolyze ಮಾಡಿದಾಗ we end up with these compounds. So, we shall see one by one. If I take XeF4 and reacting with water, that is tetrafluoride ತಗೊಂಡು react ಮಾಡಿದ್ರೆ, so I will end up with XeO3 plus Xe and I will end up with HF and O2. Now, if you balance these things students, I will directly write it as the balanced equation only 6 XeF4 ಬೇಕಾಗ್ತದೆ. So, will react with 12 molecules of water to end up with 4 Xe and 2 XeO3. How many HF left now? 6 4s are 24. So, 24 HF and how many O2? 6. I am still left 3 O2. Okay. So, this is how, that is by the hydrolysis of XeF4. Okay. Next, the important one is hydrolysis of XeF6. This will undergo hydrolysis by taking 3 molecules of water and end up with XeO3 plus HF. ಈ equation ಅಲ್ಲಿ Xe ಬರುವುದಿಲ್ಲ, O2 ಬರುವುದಿಲ್ಲ. This equation is simple. I hope you can remember this equation. XeF6 will undergo complete hydrolysis forming XeO3 with HF. Balance ಆಗಲಿಲ್ಲ 6, here I should have 6 HF. 3O, 3O. I hope you can write this. Okay. This is for the complete hydrolysis. Complete hydrolysis of XeF6. Complete hydrolysis ಆಗದೆ ಹೋಗಿದ್ದು partial hydrolysis ಆದರೆ I will end up with the other two compounds. So, I will take XeF6 plus 2H2O and one more XeF6 plus H2O. Now, in this case, what are the products you are going to get? If you just take 2H2O, I will end up with XeO2 F2 plus HF. How many HF? 4 HF. 2 into 2, 4. So, XeO2 F2 ಬರ್ತದೆ, ಅಲ್ಲಿ ಲಾಸ್ಟಿಗೆ ಬರ್ತಿದ್ದೀನಲ್ಲ ಅದು. By taking 2 molecules, that is partial hydrolysis of XeF6. Instead, if you take only just one, ಇನ್ನೊಂದು ಕಂಪೌಂಡ್ ಇದೆಯಲ್ಲ XeOF4 ಬರ್ತದೆ plus HF. How many HF? 2 HF. So, these two products are obtained by the partial hydrolysis of XeF6. Okay. Complete hydrolysis of xenon hexafluoride will end up with XeO3, while partial hydrolysis, depending on the number of molecules of water you take, we end up with XeO2F2 and XeOF4. So, these are the only methods of preparing xenon oxygen compounds. In that XeO3 is bit important. This XeO3 is an explosive students, just remember XeO3 is an explosive solid. Okay, this is an explosive solid. Now we are left with the last part on structures of these compounds of xenon. So I shall write the structures for you now. Okay, we shall see the structures of XeF2, XeF4, XeF6, XeO3 and last XeOF4. So ಹೇಗಿರುತ್ತೆ ಇದರ ಸ್ಟ್ರಕ್ಚರು ಅನ್ನೋದನ್ನು ನೋಡುವ. It has been given with the help of VSEPR theory. Now if I go for XeF2, the structure is linear, and XeF4, this is square planar. XeF6, distorted, octahedral. XeO3, this is pyramidal, and last XeOF4, idu square pyramidal. Okay, so these are the general structures, that is XeF2 linear, XeF4 is a square planar, F6 is distorted octahedral, XeO3 is pyramidal and last OF4 is a square pyramidal. So idರದ structures ಬರೆದ್ರೆ ಹೇಗಿರುತ್ತೆ ಅನ್ನೋದನ್ನು ನೋಡುವ ಈಗ. In the case of XeF2, so linear ಅಂದರೆ ನಿಮ್ಗೆ idea ಇದೆ students. So I have here F and F over here. See, you have to remember the number of lone pair of electrons which is present on Xe. ಅದನ್ನು ತೋರಿಸಬೇಕು ನೋಡಿ. We know that NS2 NP6 electronic configuration, there are 8 electrons in the valence shell. So among which 2 electrons are involved in forming a bond with 2 fluorine atoms. In ಎಷ್ಟು ಉಳ್ಕೊಂತು? Totally 8, 2 are involved in bond formation, covalent bond. So I am left out with 6 electrons ಅಥವಾ 3 pair of electrons xenon ಮೇಲೆ ಉಳ್ಕೊಳ್ತು. That you have to show like this. So these are all the lone pair of electrons which have been left on xenon. The shape is linear. ನೀವು ಹೀಗಾದರೂ ಬರಿಬೋದು ಇಲ್ಲ ನೇರವಾಗಾದರೂ ಬರಿಬೋದು. Next, if I go for F4 square planar, so I have Xe at the center. ಒಂದು ಸ್ಕ್ವೇರ್ ಇದರಲ್ಲಿ ಬರೀರಿ F, F, F and F. Now if you count the number of whatever that unpaired electrons in the case of XeF4, ಎಷ್ಟು ಬರುತ್ತೆ? So totally 8 electrons, in that 4 are used. So I am left with still 4 or 2 pairs of electrons are left as it is like this. 2 pairs. Square planar, ಇದೆಲ್ಲ ಹೀಗೆ ಜಾಯಿನ್ ಮಾಡಿಸ್ಕೊಂಡ್ರೆ you'll end up with that square planar. I am not going to do those. Next, XeF6 is distorted octahedral. Octahedral, you have the idea, I guess. So I'll write here, students. I have Xe. So this is for octahedral. I have F, XeF6. If you join all those things, you will end up with an octahedral shape. Now in this case, nodi 8 electrons, 8 alli 6 have been used to bond with 6 different fluorine atoms. I am left out with 2 electrons ಅಥವಾ ಒಂದು lone pair ಉಳ್ಕೊಳ್ತದೆ. So that I will write somewhere here, due to the presence of this lone pair of electrons, octahedral ಬರಬೇಕಿತ್ತು. 6 ಇದ್ದಿದ್ದೆಲ್ಲ octahedral ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ. Due to the presence of this lone pair of electron, ಅದೊಂದು ಸ್ವಲ್ಪ distorted octahedral shape ಬರ್ತದೆ ಅದಕ್ಕೆ. Next, if you go for XeO3, this is simple. Xe. Oxygen ಎಲ್ಲ double bonds ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ, valency is 6. So it is like this. Now if you count here the number of unpaired electrons, count ಮಾಡಿದರೆ 2, 4, 6 electrons of xenon have been involved in forming a bond with oxygen, double bond adu. I am left out with only one pair which will sit at the apex. Ammonia molecule ಗೆ similar pyramidal shape. And last XeO F4 square pyramidal anta ide illi. I have Xe 4 kade, F bariri square nalli and one double bond O. If you can join this and a pyramidal over here. Now illi unpaired electrons count madidre you will be left out with one unpaired electron. So 2, 1, 2, 3, 4 electrons hoitu, 5, 6 electrons hoitu xenon idu. So still 2 left, will form a lone pair of electron like this. So these are the structures of certain compounds of xenon with fluorine and oxygen. So just remember XeF2 is linear structure illide containing 3 lone pair of electrons on xenon. XeF4 is square planar containing 2 lone pair of electrons on xenon. XeF6 is distorted octahedral, contains 1 lone pair of electrons athwa 2 unpaired electrons. XeO3 is pyramidal, again 1 pair of electron, lone pair of electron ide athwa 2 unpaired electrons. Lastly OF4 alli saita hage idu square pyramidal containing 1 lone pair of electrons. So this is something regarding compounds of xenon. Okay. Then last bit we shall see some of the uses of noble gases. Okay students, I have listed the uses of helium, neon and argon over here. Now we shall see one by one. See, for helium, because of its non-inflammability as well as being a light gas, it is used in filling of balloons which are generally used for the meteorological observations, and even it is also used in gas cooled nuclear reactors. And liquid helium, I have already said that boiling point of helium is very less, that is 0.2 Kelvin. Because of its low boiling point, it is used as a cryogenic agent for all those various experiments which require to be done at low temperature. In that case, liquid helium is made use of. And one more use is it is used as a diluent for oxygen in modern diving apparatus. So idu nimigagale gottirbodu, when unit 2 solutions nalli Henry's law application helbekadre, you know those scuba divers, they carry that oxygen cylinder which is diluted with helium ant heltivi. So hagagi that in order to as a diluent for oxygen in modern diving apparatus, helium is used because of its low solubility in blood. So you know all those consequences what generally happens when they go deep inside the sea. Okay. So these are the 4 major uses. Being lightweight, it is used in filling of air balloons in order to observe all those meteorological changes taking place. And as one more is it is used as a gas cooled nuclear reactors nalli using baratido. Liquid helium boiling points tumba low irodrinda, it is used as a cryogenic agent for various experiments which are generally carried out at low temperature. And last one as a diluent for oxygen in modern diving apparatus, wherein which that helium has got low solubility in blood. Next, if I come for neon, neon is generally used in discharge tubes or fluorescent bulbs. Generally, ನೀವು ಈ ಅಡ್ವರ್ಟೈಸ್ಮೆಂಟ್ಗೆಲ್ಲ ನೀವು ನೈಟ್ ಟೈಮ್ನಲ್ಲಿ ಶಾಪ್ಸ್ ಎಲ್ಲ ನೋಡಿದರೆ ದೇ ಆರ್ ಯೂಶ್ವಲಿ ಡೆಕೋರೇಟೆಡ್ ಬೈ ಕಲರ್ ಬಲ್ಬ್ಸ್, isn't it? That is generally neon bulbs. Neon is usually filled in those bulbs, and it also finds use in botanical garden as well as greenhouses. Even here also they make use of neon bulbs. Next, argon. Argon is generally used to provide inert atmosphere. So, usually in high temperature metallurgical processes, we usually make ನಮಗೆ ಎಲ್ಲೆಲ್ಲಿ inert atmosphere ಅಂತ ಬೇಕಾಗ್ತದಲ್ಲ, so there we generally make use of argon, and even it is used for filling electric bulb. Electric bulb nalli saita we make use of that argon. Even argon is used for some laboratory purposes also, wherein which air sensitive substances annella handle ಮಾಡಬೇಕಾದ್ರೆ we usually make use of argon. There is no specific uses for krypton and xenon given to you students, so I don't mention anything regarding those. So these are some major uses of helium, neon and argon. So with these uses, students, I shall wind up at this stage on the concept of noble gases. In this session on noble gases or group 18 elements, we have listed the noble gases, that is helium, neon, argon, krypton, xenon, radon, and a new one, oganesson, with atomic number 118. Next we have listed some periodic properties and their variations, what generally happens, that is atomic size, electronic configuration, ionization energy, electronegativities. We have seen some physical properties as well as some chemical properties. Usually they are chemically inert, but in 1962 it was Neil Bartlett who accidentally prepared a compound of xenon, and now we have compounds of xenons also. We have seen some compounds of xenon, that is xenon fluorine compounds as well as xenon oxygen compounds. Their methods of preparation and reactivity have been discussed, and lastly some structures of all those xenon compounds have been told to you, and finally the uses of these helium, neon and argon. So with these things I shall wind up at this stage. Thank you.